And the short way of evaluating is plugging in. But you had to identify where the x is in order to know where to plug in. And so for number 16, did you guys plug in? Now, some of you might not have liked the f of x, but that's okay. He's just kind of a name. He's a more complicated name than y. He's a function name, but that's all right. Did you still do 3 times 2 to the power of
1?
Careful. Negative 1. Okay. In our exponent books, if you guys got this one wrong, can't we flip to our exponent books and remind ourselves of what the negative exponent means? What does the negative exponent mean? You turn it into a positive, but only after, ooh, where are we? Here we are. You turn it into a positive, but only after you cross the line, right? So we don't actually have a fraction yet, but it'd be nice if we have a fraction. Because if we have a fraction, we just have to take that expression, have it cross the line, and then we get to change the sign. Now, as we're looking here, though, how could we make 2 into a fraction to cross the line? It'd be 2 over what?
1.
So couldn't we have made this into 3 times? Wouldn't that have put the 2 in the denominator? And then the 1 up top. Now careful, it's not 3 and a half. It's not a mixed number. It's 3 times a half. And so what would 3 times a half be? Ooh, hold on. Fraction multiplying. We didn't do so great yesterday. Don't we have to put the 3 over a 1 also? And then we multiply across, and what do we end up with? 3 halves, which is exactly what the answer key showed us, right? Let me try to make this a little bit bigger. Nope. That's fine. Won't let me go any further, so that's all right. We'll just say 3 over 24. Okay, number 18. You guys know what 0.5 is, right? I don't like decimals. Some of you do because you use your calculator, or if we're talking about money, it's always decimals. But yeah, fractions are actually in many ways a lot easier. With a calculator, you would have had to do this one by plugging in 0.5 and finding the exponent button to plug in that negative 3. I actually would have much rather had this be a 1/2 to a negative 3. That negative exponent would do what with this fraction, guys? Flip it, and so it would actually be 2 over 1, which is just 2 to the 3rd power. I like fractions better because I can do this math without a calculator. This one you'd have to find that exponent button. This one you just get to say, oh, hey, I flipped my 1/2 because of the negative exponent. And what is 2 times 2 times 2? 2 times 2 is 4, and 4 times 2 is 8. Yeah. Remember, we have to do the cubing, so it's 2 times 2 times 2, not 2 times 3. See that? So that would be 4. Yeah, which is 8. Is that easier?
Yeah.
Okay. Now we still have one more. We still have number 20. This was actually, yeah. Yeah. What's up, Hannah?
If it was a fraction and it was a negative, can you do either in the first one and just flip it?
Yeah, which is what I did.
But how'd you end up with 2 different?
Oh, because, yeah, this one was a 2 to a negative, and so when I flipped, it went in the denominator. But 0.5 is already 1/2, so when I flipped it, it became 2. So they went like different directions.
Oh, you're just not writing as a fraction.
Yeah. Sorry. You could have made it 2 over 1. Does that make sense? But then when it's over 1, you can kind of either put the over 1 there or ignore the over 1 like we usually do. Yeah, sorry, I didn't show that. Oh, it's me knowing what 0.5 is as a decimal. 0.5 is 5/10, which reduces to 1/2. It's a decimal that a lot of people, like 50 cents is half $1. It's just a decimal a lot of people know as well. Yeah, I didn't do the math for that, sorry. But if you think about it as being 5/10, then I just kind of went to 1/2 real fast. Now for number 20, do you guys mind if it's getting busy over there? Let's come on this side. What's the power? Ooh, that's a nasty power. This is probably the hardest one as far as plugging in. Because it's to the 3 halves. Now, this is what we call a rational exponent. Yeah?
Yeah.
Wait a minute. Rational exponent. Didn't we have a quiz on this the other day?
Yes.
Yes, we did. It was the one where we were changing rational exponents to go into radicals and radicals to go into rational exponents. Can I give this back to you guys real quick? And then you can look at this and say, huh, from the quiz, do I remember how to rewrite this in a way that makes more sense in my brain? Oh, these are some older quizzes too. When you hear your name, come on down. Andrew? Joseph? You make it. Andrew Swanson, sorry. Woo! There's a lot. Oh, these are put on my web yesterday, I believe. Alyssa, this was earlier one. Trey, Everest, Andrew Bosch. Isaiah. Melanie, Jonathan. Andre. Sunny. Adrian. Alexis. Jason. Armando. Levi. Daniel. Caleb. Andrew Casper. Oh, they're all back in that picture. Andrew, sorry about that. There you go. Got it? Sean. Yeah. Caleb. Brooke. Diana. Jerry. And Jerry. Okay, now hold on. Look at your quiz. When I grade it, I try to show you what went wrong. Now, guys, remember you're holding on to these quizzes because they're going to be good things to review for the test. And there are going to be some opportunities for some points back. You don't want to lose them because we're going to try to go over your mistakes. Because to be honest, are these quizzes, when we take these, are you supposed to have everything perfectly mastered, down, pat, able to teach on it? No. But you're supposed to have kind of learned it, right?
Yes.
We do homework, we go over questions. By the test is when we want it like really down solid. So we're going to be revisiting these quizzes. You guys can come in and talk to me about them. We can do sample problems. There are going to be some opportunities for points back as the test gets close. We're going to have another one this Friday. It's our homework quiz from this week. But can we just look at the rewriting section? A lot of you guys did really well on the rewriting section. Wasn't there a rewriting section or a rewriting problem that had one of these rational exponents? Now, some of you did it right in the rewriting, and some of you switched it. So help me now. Look at what you did. Look at what I graded. Did you do it right, or did you switch it? And how would we rewrite? Okay, leave that 1/4 separate. How would we rewrite 4 to the 3/2?
Oh, yeah.
Yeah, Daniel.
The square root.
Good. Square root. And what's underneath? The 4. So what exponent?
30.
Yeah, good. Now, you could have put the 2 in here, and some of you did on the quiz. I forget. No, I don't think it was a 2, was it? It was something different. You could put the 2, but it's understood, so you don't need to. So that's totally fine. But the problem is, and when we were grading, they went further because actually, yeah, can't we make 4 into 2 squared? Now we're kind of doing the evaluating on the second part of the quiz. We can make 4 into 2 squared with this whole thing cubed. Guys, do you remember what happens when we're looking for groups of 2 and we find one? Yeah, cancel. So you can get rid of that with this, and what's left over is going to be 1/4 times 2 cubed. Now then come up here. So when I found my pair, when I found a group of 2, I was able to cancel out the radical with the group of 2. Pretty good. And when I cancel it out, I have a 2 cubed left. I have a 1/4. I'm going to keep the 1/4 because PEMDAS says exponents first. Didn't we just talk about 2 times 2 times 2 is 8? And then we can make that into a fraction like Hannah was saying, because I wasn't writing all that work earlier. So 8 over 1. When I multiply across, I get 8 over 4. And what's my final answer? Got it. Out of all of these, though, number 20 was definitely the hardest. He was definitely the hardest. Now, guys, in the next part of homework. And the next part of homework. Armando, why are we talking? Okay, the next part of homework, we had Andrew Bosch who was asking some questions on the matching. But also, I think, was it Isaiah or Trey yesterday? When I had this up on the screen, you were already starting to make matches. You were like, oh, hey, wait, I see it. That was you, Trey?
Yeah.
What did you see yesterday? Because you were totally like, oh, wait, and I had to quiet you because I was like, I want them to think about it. What did A end up going with? What did A end up going with? You guys remember?
23.
Yeah. Because this was a normal exponential graph. It was swooping up. It's called exponential growth, but that's okay. It was swooping up. And the normal one, the most normal one up here was 23 because it had a positive number outside, a positive number inside, and it was just growing. You could have made a table, but yeah, it was just growing. But hold on, one of them was decaying or decreasing like we saw yesterday. Which one looks like the one that we did yesterday in our opener?
22.
Well, actually both of them, yeah? 21 and 22 both have fractions inside, and fractions are going to decrease. Now, hold on. But we can't have 2 going to 1, so both of these are decreasing. Smaller and smaller and smaller numbers, but one's a positive and one's a negative. What do you think is going to go with the one that's on top? Because these other ones are down below the x-axis, right? Yeah, 21. Good. 21's the positive one, and it's a fraction inside, which means, oh, it's doing what we did yesterday, the 16 to the 8 to the 4 to the 2 that's going down. But it's a positive. Now, these get a little tricky because do you guys notice what happened then? If both of these go to both of these, all right, we're left with these two to make matches. Both of them have negatives. What must negatives do then to graphs if it makes it like this? How could you guys describe what happened to our graphs? What's different from here to here? Or here? They? Yeah. And the snazzy math term for foot. Did you guys learn that last year? It's reflected, like a reflection in a mirror. Have you guys ever noticed when you look in the mirror that you're kind of like backwards?
Yes.
If you hold up some writing to a mirror, isn't it backwards?
Yes.
Because it reflects, because it flips. That's what's going on here. The graph got reflected, like there was a mirror kind of. It got reflected or flipped because of the negative. Now hold on. Don't we have our notes that we were just talking about, or you guys were just writing stuff about graphs? Can we go back to that picture or those pictures that you drew? What do you notice about the blue and the red? The blue's our normal one. That's when the number in front is a positive. And some of you, the greater than 0 gets really complicated. So it might be better if we just say the number in front is positive. We're going to be swooping up. But when the number is negative, do you see now this reflection down below? Yeah?
Down.
Yeah. Now, hold on. Wait, there's two different graphs. Because this one also has a positive, doesn't it? And a negative? A positive? Wait a minute. This one's swooping down, but not the same way. Right? So what else is different? That's it. That's one way of describing it. Or you can think in a way, these ones up here are going away from the axis. We could actually kind of say that they're growing. They're growing away or they're growing away. They're kind of like trying to get away from the axis, whereas what are these two doing? They're going towards the axis. So it's kind of like if you guys have ever talked about magnets, you know, sometimes they attract and sometimes they repel depending on the charge. I don't know if you've ever talked about magnets. Or there's the ones where you can like do magnet art with like little flakes and then it either comes towards or like it pushes it away. There's some cool videos with those. These ones are like being repelled and these ones are kind of being attracted. But the difference is whether B is big, like a 2 or a 3 or a 4, or whether B is small, like a fraction. So if we have a small fraction, then it's going to be attracted to the axis coming in. And if we have a big base, then it's going to be repelled. Anyway, all of that to come back to, where are we? Here we go. Our matching. With that information, we should be able to make our final two matches. So we figured out the normal one went with number 23. That's kind of like the parent function. The one that was, instead of growing, that was decreasing, well, that was that little fraction guy, number 21. Now, hold on. Which one is going to be coming in towards the axis rather than away? We know that they both got reflected because of the negative. Which one's coming towards and which one's going away?
D is going away, B is going forward.
And so which equation goes with away and towards? What would the 0.5 be? Would that be coming in towards the axis or would that be going? Good. So this one's towards, so 22 goes with B. And this one, since it's a bigger base, is away. Is letter D. Woo! So, yesterday, if I had put this in your notes, I think you guys would have been like, huh? I mean, maybe you would have gotten it, but maybe not. But last night, you faced a homework where you were trying to look at the pattern and trying to figure out what's going on. So I used that in order for us to say, okay, so sometimes the swoops swoop up or swoop down. Sometimes they're reflected across when there's a negative. But they're either going away or they're going towards. There are some things that we could study, that we could practice. But guys, where did you get stuck in homework? It wasn't too much, I don't think, except for a couple harder problems until what was different in this section? Number 25 through 28. Why was it harder? It was, I totally agree. But why? What was the main goal or the main objective it was asking you to do? Isn't it graph?
It's hard because I didn't know what the X was.
Yeah. Okay, so I'm going to go ahead and steal these two first. Does anybody remember what I wrote yesterday as I was introducing homework? That you were supposed to, somebody took a picture of it. Do you still have it on your phone?
Yeah.
What did I write down yesterday as far as your holidays?
Label 26, 25 through 28.
Good. It was 25 through 28, and then what did I say to do? Make
Oh,
a...
can I look?
Yeah, you can look.
You
Yeah, like a
said
cheater chart, but more like a table.
make a table for graph functions, and you crossed out describe the domain and range of L.
Okay. Good. So make... Now, some of you, and I just heard one of you say this, you were like, I didn't know what to put in my table. So when we talk about what to put in your table, now some of you, your homework was kind of incomplete, and I gave a little bit of grace just because we were going to go over it right now. So have your homework out on number 25. Some of you did a great table, and some of you didn't. Some of you might not have gotten your homework done, so do it in your notes, and then you can have it in order to help finish your homework later. Now I'm going to do an X and a Y. My people that did make tables, can you just give me some advice as to numbers that you use? Because I didn't tell you what numbers to use. I didn't make the table for you. I just told you to make one. Yeah, I like 0, 1, 2. And technically, to be really safe, a -1 would probably be a good idea. So for those of you guys that didn't, I don't know if we're going to get to number 27 and 28 today. I just want to show you maybe 1 or 2 of these. I would have done -1, 0, 1, 2. So that should give us enough points to see which way the swoop is going. Now, some of you, look at your sketches. Those of you that did make graphs, some of you, I can see the swoop up, or maybe it's reflected swoop down going away, or I can see the decreasing swoop towards, and it's reflected one as well, but some of you have some funny points, and if you have funny points, it could be because the plugging in got a little bit rough, so we have to be really careful with the plugging in. Some of your graphs, I'm like, I kind of see it, and I kind of, bless you, don't. But from what we talked about earlier, guys, what would make this problem a lot easier to plug in? What if we changed the 0.5 to what? Yeah, that would make life a lot easier. We're going to be plugging into that X spot. And then this one's kind of okay the way it is, but some of you might have been confused by what was going on, because aren't negative numbers illegal bases? Except, are there parentheses? Yes or no? So actually, it's a -1 times 4 to the x. Or we could even do negative 1 times 4 to the x all in one parenthesis. So that might have thrown a few of you off on that one too. Plug it in, plug it in. So either you're doing this in your notes, or you're making sure and checking your homework. Now the nice thing is, on a test, I would probably make the table for you and just ask you to fill it in, and then I would give you like an X and Y and say, now sketch it. So I would be a little bit more precise than the book was. That might help you guys also. But if you were to plug in, I'm going to do it kind of fast because we did a lot of plugging in work yesterday and even today earlier in the homework. If I was to plug in negative 1, we would flip the fraction, and 3 times 2 would be 6. I'm going fast, but you guys did a lot of plugging in homework. You would just have to go point by point, step by step. But you would get 6. So at negative 1, you could go up to 1, 2, 3, 4, 5, 6. Got it. Now 0 is the nicest one ever, because what happens when I plug in 0 to an exponent?
1.
But remember, only that power becomes 1. What's also there?
The 3.
What's 3 times 1?
200.
Wouldn't it be on the bottom?
Not quite. Wouldn't what be on the bottom?
The 6 because it's negative 1.
Oh, good question. Remember when I have, can I write it real quick? When I do 3 times 1/2 to the negative 1, I actually just flip. Remember, this 3 is to the first power, so he stays. The net.
Oh, I'm talking about like graph. When you graph negative 1 to 6, when you go down.
Oh, no, because the 6 is a positive. So I'm going up. So the negative, I go left, and then the positive 6, I go up. Sorry, the 6 makes sense. When I plug in 1, it's going to be kind of nasty. It's 3 times 1/2, which is 3 halves. We saw that earlier in homework, which would have to be 1.5. We have to kind of approximate. But do you guys actually see what it's doing before we even go into the 2? Do you see what kind of swoop it is? It's coming down, so it's going in towards. We could actually draw it and not even have to do that last one because we figured out what's going on, which is kind of nice. Now, if it's on a test, you might want to fill in the entire table because each separate box is separate points. But in homework, we just had to get enough to see the trend and follow the pattern. And so we would do a similar thing with this one as far as plugging in. We would actually have to flip the 4/1 because of that negative power, so it'd be negative 1 times 1/4. So some of you would have probably needed to take up quite a lot of room, making the table on one side and the graph on the other, taking your time and plugging in for each box. But this one's weird because it actually starts something really tiny. Negative 1 and negative 1/4 would be right about down there. It'd be left and downward. Oh, 0. Woo, we like him. He's easy. If I plug in the 0 power, what does the 4 to the 0 become? 1. And 1 times? Negative 1. Be negative 1. Some of you might already have a guess as to what this is going to do. Because it's reflected. Oh, that's going to be a negative 4. That's going to be a negative 16. But do you guys already see what it's doing? Is it going towards or away? Totally going away. And it's that reflected one down. Maybe we can actually draw this guy real fast. Okay, so exponential graphs, they do all kinds of different things. As far as swooping up, swooping down, going towards, going away, and we haven't even necessarily talked tons about this page in homework that, wait, this has something totally different. Do you guys see what's crazy and extra to the equation in these ones? Adding and subtracting. Yeah? So if we have adding and subtracting, actually, if you guys just want to fill in some couple of hints that might happen, if we have an x minus h, this whole swoop is actually going to be shifting in the snazzy math term. Actually, translation is the really snazzy one. Shifting to the right. So the whole thing is going to be shifted over to the right. Or it could be shifted to the left. There are exponential graphs that can have have these translations and have these shifts to the right, to the left. And if you can shift right, left, guess what else you can do? You can also shift up and down. So this whole like plus K thing is actually going to be moving it. You want to draw a little arrow? Depending on whether K is a positive number or a negative number, we could also shift in other directions. So the graphs do get way more complicated, but we're not going to go super crazy on exponential graphs and doing all of the most complicated ones. What I want you guys to do for the last few minutes of class, I'm going to pass out the puzzle time. This is the worksheet for tomorrow. And I want you guys to find for me the hardest problems, because we're going to take just a few of the hardest problems. Because if we were to start the worksheet all together, do you guys realize the easier ones are usually best? Maybe let's not try the easier problems. Let's try a couple of the harder problems all together. Get your name on your worksheet. This is homework for tomorrow. Then I want you to look at those problems at the end. Well, I'm guessing they're at the end. You guys help me out. Let's find the ones that look to be the hardest, and maybe we can do a couple together. Does that sound good?
Yeah.
Okay. Still have a few minutes left of class. We could start at the beginning, but once again, I think those are usually the easier problems. Instead, let's start towards the end. As you guys are looking at this, and as you are looking towards the end, did everybody get one just real quick? Double check it. We're good.
How do you find your train? On the train track.
That doesn't fit. Good try, though. Alright, can you guys help me out? Can you find one on this worksheet that looks hard that we can try together? Yeah, Andrew Bosch, what do you see?
13.
13. Alright, let's go down to number 13. Oh, yeah, he's a mess.
Number 9.
Number 9's a mess, too. But he's like one of the ones that we did today in class, right?
Yeah.
Okay, so let's peek at this whole bottom section, because if you guys notice, this whole bottom section looks really weird, because we haven't really done these problems, yeah?
Yeah.
Okay, now if number 15 is the only one you don't get, I bet you'll figure out the answer to the riddle. But if you don't get these 4, we could be in some trouble. Describe the domain range. Can I give you a hint real quick? Domain X and range. Domain is actually for all exponential, all real numbers. So we don't have to worry about domain. For every single exponential function, the domain will always be all real numbers. So actually, we don't need to worry. Can I split x though? Is that okay? For all exponential functions. The domain is all real numbers. But the range gets tricky. Because the range for either of these ones, if we have like a swoop that goes up, a normal one that's above the axis, either a swoop that goes up or a swoop that goes down, either one of these, if we're talking about above the axis, it's going to be y greater than some sort of number. But if it's one of those mirrored ones, if it's one of those reflected ones where it's swooping down, or where, let's see how they can swoop, oh, towards, then it's going to be y is less than k. Wait a minute, who's k? We just talked about him a second ago. Oh, he was in our notes, wasn't he? K is this guy. So for range, either y is greater than k if it's above the axis, or y is less than k if it's below. Can we check out these graphs and see if we can help each other out as far as how to, there we go, figure out what's what. In this one, k is 3, right guys? What's k in this one? Good, but careful, there's that negative, the minus sign in front. What's k in this one? What's k in that one? Negative 4 is up here in the H spot. Do you guys realize there's nothing there? And if there's nothing there, what do we say is there? If it's an atom, yeah, we say 0. So maybe that's enough to make matches, but if you guys actually started making little baby tables and followed, do you guys realize this is going to actually be one of those swoop ups? This one is going to be one of those negative. Oh, it's below the axis. It's actually going to be one of those swooping down and towards. This one, it has a bigger number, but it's positive, so it's going to be a swooping up. And then this one's going to be a positive number again. Maybe that'll help you, just having little baby sketches. If I were you, I would show the little baby sketches on 11, 12, 13, 14 before you leave the classroom. Because that will help you if you know what the keys are. And stay seated. Dismiss it. If you take a picture of this on the way out the door, it'll be helpful. I think it'll help you make the matches that you need. Sound good? Alright, okay, section 6.3, worksheet. See you tomorrow. If you have any questions during lunch or after school, or if you have any late homework or other things to show, or questions on your quiz. Bye guys, thank you so much. These will help, these will help. Usually every Friday.
Bro, they don't know anything. That was late.